So we skip the chapter on radical equations and go straight to inequalities. And this first batch of inequalities are purely linear inequalities. So we solve them just the same way as linear equations, but we retain this one rule that when we multiply or divide with the negative number, then the direction of the inequality changes. Otherwise, it is exactly the same pattern. So in part A, one remark though is that when we have an inequality between two fractions, don't apply the cross rule, because the cross rule doesn't tell you which product to put on the left and which on the right. The order does not matter when it's an equation, but with an inequality, it is not. I think you can just write, well, 3x minus 2 times 9 is larger than 6 times 4x minus 1. But if you don't pay attention, you flip the order around, you write the 6 times 4x minus 1 on the left-hand side, and then your inequality points in the wrong direction. So I would in this case recommend that we just multiply both sides with the least common denominator of 6 and 9, which is 18. So this gives us 18 over 6, 3 on the left-hand side, times 3x minus 2. And on the right-hand side, we get 18 over 9, 2 times 4x minus 1, 9x minus 6, 8x minus 2. We put the 8x on the left-hand side and the 6 on the right-hand side, and we get x greater than 4 with a strict inequality. Number B, to get rid of the fractions, I would we can multiply with 6. That gets us rid of these denominators. Not yet of this division by 4. So x less than or equal minus, now 6 divided by 3 times, no, 2 divided by 3 times 6 is 4. And now you see that when we expand the bracket, the division by 4 disappears. So x is less than or equal negative x minus 1 minus 8. Now we have plus 1 minus 8 is minus 7. We add x on both sides. 2x less than or equal minus 7 divided out 2x is less than or equal to minus 7 over half, 7 over 2. The inequality is not strict, so we put a square bracket. Number C. Again, let's get rid of this division by 5 by multiplying the whole inequality by 5, but this 2 inside the bracket remains for the moment. Now 7r times 5 is 25r. And we open the bracket. Now 14 times 5r plus 3 over 2. You see now that the division by 2 cancels with the factor of 2 in the 14. But of course there's a hidden bracket in the fraction. This minus sign has an effect on this plus. It will change this plus into a minus. Now Let's simplify the right-hand side. 35r minus 21. And if you look closely, you see that everything cancels out. So 0 is less than 0, which is an obviously false statement. So no solutions. Finally, problem number D. We have three fractions. We put them under the same denominator, which is 12. So we need a factor of 3 in the first fraction. We need nothing in the second fraction, and we need an extra factor of 2 in the third fraction. And now we can just cancel out these. We in effect just multiplied the whole equation by 12, and you could have just done this multiplication at this point. That is instead of writing the division by 12 at each step for each fraction. In any case, we are now without fractions, and we can solve this simple linear inequality. 6 minus 3x, 5x minus 3, 2x. Now minus 3x plus 5x gives us 2x. 6 minus 3 is 3. Oh look, x disappears. We are just left with 3 greater than equal than 0. So any x will make this true. And there are no forbidden values. So all of R is the set of solutions.